So what had we discussed in the last class about? PLCs, right? We saw the operation, how the what is the there were the basic steps, okay, as to how a PLC operates, right? As we saw, it firstly reads all the field input devices, right? It checks the status of the input devices via the input interfaces, right? That's where you have the uh, communication between the input devices and the actual PLC, the CPU of the PLC. And then it executes the user program, right? Stored in application memory, and then performs whatever control is necessary for the process application, right? So whatever is it that has been programmed performs that. So, and then we saw that a process is there called scanning, right? Wherein you read the inputs, execute the program, and updating the output. That process is what is called as scanning, right? And then we saw the different scan cycles in the PLC. Okay, as to four phases, we can divide them into. First being your input scan, and then the solving or the program execution, and then diagnostics, right, to check, and then output status scan. So whatever values have been sent to the output, right, after the program has been solved, right, executed, the values will be sent to the output devices, right? So the condition of that, right, of those outputs will be taken, okay, so that it can be recorded, and then that will be stored, okay, for future uses, because we want to know what is the status of that input output device. For example, if the motor is on or off, right, like that. So those were the four phases. Doubts from your last class? No doubts, okay. So as for the advantages of PLC, you see there's very less wiring as opposed to earlier relays. You see there's not much wiring involved, only you'll have a connection between the uh, input and output interfaces, right? That's your input terminals, and those are your output terminals. So as opposed to relays, you have very less wiring, right? Because mostly it's software based, and you have communication only when you have to have communication between the input and the output devices, you will require that wiring to be there, right? So that's why we are saying very less wiring, and wiring between devices and relay contacts are done in the PLC program, right? Because how you're connecting those things is all through program, right? You have written a program, so that's in your PLC programming. When you do that, cost effective, because you see, as and when software technology is evolving, we are now having cheaper softwares, right? And not much hardware is involved here also, uh, because you're able to do it quickly, isn't it? So that also affects the easier and faster to make changes, right? Changes in the sense, if you want to change that ladder logic program, for example, right? That is a standard way that we are programming it, right? I told you about ladder logic program, isn't it? Yes, there are still only 18 participants, right? You see, that program what you have written, you can change it dynamically, isn't it? Because either you can do it inbuilt, like on the PLC itself, basic manipulations you can do, right, in here. Also, if you connect it to a programming device, then we can alter the program, right? Either you can change it right when you have connected it, okay, dynamically, or you can change it in your programming software and then connect it and basically download that or insert that program in here. So that is why we say that we have easier and faster means to make the changes. Troubleshooting aids make programming easier and reduce downtime. So you see, if at all there is a problem in the system, something is wrong. Okay, that's when you say that you're troubleshooting, right? You're trying to find out what has went wrong, right? Troubleshooting. So troubleshooting aids make programming easier. So uh, when you have this display unit, right, and it interacts with you as to what is wrong, right? So that will make troubleshooting easier to find out where exactly is the fault. Either the program is wrong, okay, or there's some problem with the program structure, or there is it that some input devices scanning has not been done, problem with the input devices, or the problem with the output devices, okay. So that makes it very easy, because in the industry, you want to have we do not want delays, right? So downtime is the time when you're not actually, it's a non-productive time, you can say. So when the equipment is not functioning, okay, whichever equipment this PLC is attached to, it will stop functioning because the PLC is not working, right? Downtime. So that will be reduced because of those troubleshooting aids that we have. Flexible, reliable, and compact, right? Because you can install them. You see that unit what you saw, you can install it. There are what do you call, uh, because it's a compact unit, can be installed anywhere, right? Flexible in the sense you can just remove it from some place, okay, and place it wherever is it that you require, right? So that will make it uh, flexible, you can say, in a sense, right? You can install it anywhere. It is a compact unit, it is reliable as well, because troubleshooting and all, we have made sure that the downtime is reduced. So that makes it reliable. Significant advantages over traditional control systems based on relay or pneumatics. Okay, so wait for a minute, okay. Okay. So you see significant advantages over traditional control systems based on relay or pneumatics. So we had discussed, right, all of those advantages, that they are compact, right, because require very less space and connections are very easier to make. As for relays, you will have, I believe we saw a video, right, for PLC, that and in that video we saw how those relays were connected and what is the problem with using relays, right? Yes. Yes. Initially, right, we saw that for the PLC operation, and it also mentioned of the relays, right? So that was your PLC. Okay. Doubts regarding any doubts regarding that PLC questions? No doubts. Okay. You see, as for microcontrollers, it's a compact integrated circuit designed to manage devices that consist of a control system. They're embedded devices that have processor, memory, and input output control in one unit. So, in essence, we can say microcontrollers serve the same purpose as a PLC. Okay, a microcontroller is a compact integrated circuit. Okay, designed to manage. It's a circuit, right? You see here that integrated circuit is designed to manage devices that consist of a control system, right? They have processor, memory, and input output control, right, just as you had it in PLC. Okay. uh, they can perform operations from simple ones to advanced. And what are those? Mathematical operations, right, logical processing, right, based out of the program that we have fed, serial communications, wireless communications as well, pre-processing of data for machine learning, right, that is another application, controlling devices for a DIY smart home. Because even what is DIY? It's a very common word, right? Yes. You see, we call it do it yourself, right? That's usually with uh, things that we have at home. Okay, simple things. So you do it by yourself. So for those devices, right, even those consist of microcontrollers reading data from both analog and digital devices, right? We have discussed what are those devices, right? Analog and digital devices. What do in analog, which of that two will have the, what do you call, digital is what we have now, right? Previously we had analog, and even now also we do have, like for example, uh, I gave you the example of that switch, right, on and off, right? That's how digital devices operate, either either of the two, right? On or off, one or zero, like that. Analog will have a variation in the signal and variation in the value of that signal, right? So that's what. So when you are trying to read data from both of those devices, right? Even that can be done. It's also common for multiple microcontrollers to be used to handle varying tasks, right? If at all they are required, multiple microcontrollers can also be used. For example, a car will have one microcontroller for operating the speedometer. As you see, that's the application we are talking about. Another for the auto braking system, and yet another for the powered windows, right? Or each of those requires a specific microcontroller, right? So one microcontroller for each of that to operate the speedometer, right? We have the speedometer which displays the speed, auto braking system, right? Because to be able to apply brakes, we have that technology, right? ABS. Heard about that technology? ABS, in terms of under the domain of braking. No, anti-lock braking system, right? So you are trying to give the signals to the brakes. I mean, we're trying to stop the vehicle by not continuously braking. Okay, it's not like the brake disc will continuously press the brake pad. That disc, what it will do is it will intermittently do so. Like for example, for a millisecond, it will press the brake disc, okay, and then it will leave that, okay, not continuously holding it for braking. So milliseconds, within milliseconds, you will press and release it, okay, press and release the brake disc. So that will ensure that the vehicle does not slide, right? So that was briefly your braking system. So that requires your microcontrollers, okay, another application. So what time should it start pressing the disk and release it, okay? So that is happening in milliseconds, right? So that is why it requires these microcontrollers, right? And all of that will be coordinated, right? Because the brake disk will have to, that the input from the brake disk has to be given for us to know whether it is in pressing mode or releasing mode. So that, and yet another for the powered windows, even for the windows, right? Earlier you used to have that lever, now we have it with the button, right? With a click of a button you can move it up or down. So that is also controlled by a microcontroller, okay? Just next, you see, that's how a microcontroller looks like, okay? How does it work? You have a, as we had mentioned, a processor, a data memory, program memory, input output control, and supporting circuitry, as is for general, uh, it is generally there, right? So data from a device's various inputs are received, okay, from the microcontroller's input output, okay, just as you had in for PLC, right? Inputs are to be received first and temporarily stored in the memory, right? That's why you need the memory. And the processor then analyzes the data to determine the appropriate response, right? So data is to be fed, and response, it depends on pre-programmed instructions, right? Instructions are being fed, and based out of that the response will be given, stored in the microcontroller's program memory. Because you see that two divisions, data memory and program memory. One is for storing the data, that is the input data that you're receiving. The other is for program memory, that is for your to programming data to reside, okay? Your program also needs space, isn't it? So that your pre-program instructions will be stored in your program memory. Processor finally uses the input output to communicate the response and perform an output function, right? So when that is executed, those instructions are executed based when upon feeding of the input values, then you will perform an output function. So it asks, the microcontroller asks the output device to perform an output function, right? Could be anything, as we saw the different applications. Could be sliding a window up or down, or your braking system as well. And another one was your what was it, speedometer as well, right? So those could be the output responses that you would see. Okay. Now, microcontrollers, although microcontrollers are significantly less expensive to obtain and compact in size, manufacturers still prefer PLC. I told you, right? You can use a PLC as well, or a microcontroller. Okay, as far as industrial applications are concerned. So, but still, manufacturers are preferring PLC. Okay, in the industry, manufacturing industries, PLC is being preferred over microcontrollers. Why? Because of all these reasons. Okay, we'll see now. So, user friendliness. You see, know-how and programming of PLC can be learned easily. So, in order for a device to be popular, it has to be easy to use, right? So, it has to be user friendly. So, and how does that become user friendly? When it is easy to operate, easy to learn. Okay, how to operate the device. So, the know-how and programming of PLC can be learned easily, right? All that ladder logic programs, etc. How do you do that? You can there's a lot of information from the manufacturers also, and it is easy. Okay, has been made easy. Short learning curve, you can learn it very easily, right? Does not require much time. Controlling the devices doesn't require a lot of interfaces in PLC over microcontrollers, right? As we said, interfaces are very less as opposed to your microcontrollers. PLCs have does not require a lot of interfaces. So ease of programming, right? The way you program that. As for relays, you have to connect it from one to the other, and there are also mechanical units involved inside the relay. So that will cause some problems as well, because of wear and tear, or the speed of response is also another factor, right? And ease of programming, you can program it very easily, right? Now, have you has anyone informed your friends? I already posted in the group, right, regarding the quiz. There are only 19 participants. Hello. Am I audible? Hello. Hello. Yes. Okay. You see, how many quizzes have been conducted earlier of other subjects? Only one has been conducted. Okay. And how much was the strength? Was it like this? Like there are only 17 participants now. One per unit in EM and M course. So was the strength just like this? Like almost 20 or something. Average responses by 25. So others missed it. Is it? I'm not sure whether I should conduct the quiz or not. Because if you don't attend it, then there is no other chance, right? Okay. Okay, then we'll see if today's 5th. Okay. Okay, then. So when is your next class? Tomorrow you have a class. Yes, afternoon. So tomorrow and Friday also, first hour. Okay. Okay, then tomorrow we will conduct the quiz. Okay. Hopefully. Tomorrow, yes, afternoon you have the class. So tomorrow afternoon, I'll put in the group. Okay. And we'll conduct the quiz. Okay. So you see, that was the reason why they are user friendly. Okay. PLCs. Okay. What we are talking about is the reasons why PLCs are preferred over microcontrollers. Okay. So PLCs are more user friendly than microcontrollers. That's what we mean. Okay. Because of all these reasons, right? Ease of programming and does not require a lot of interfaces. Okay. Short learning curve, very easy, right? Know-how is uh, easy. Okay. Can be learned easily. You have short learning curve, different what do you call there are even different uh, ways of programming it. Okay, there's not a standard way. Different programming, what do you call those software programmers, uh, different companies have come up with different standard of programming. So that is another reason. Modular design. Modular PLCs serve as plug and play systems in industrial applications. As I said, you can install it right wherever you want to, and all you require is that unit to be placed. Right, we saw that unit. So you have that racks wherein you'll place them, right? So that is why we call them modular. We've discussed about modular, right? Why do we call them modular? We have heard this word modular, right? When we were talking about rigid automation. So rigid automation, we said that modular units were being used. Modular in the sense they are units by themselves. Okay, they can be attached anywhere. Okay, to in combination with other devices or other uh, what do you call it can be interfaced, right? So PLC is a modular unit, right? So serves as plug and play system. So you just install it there, attach the wiring. Okay, if at all a program is needed, you install it, either download it or you directly connect it to a programming device and program it. So faulty modular units can be replaced, avoiding delays. Another advantage that you get because of that modularity is you can replace them, right? If at all there is a fault and you find that a PLC in a setup is not functioning properly, you can just replace that. So that avoids delays, isn't it? Delays can be avoided. Instead of having to stop the whole production line or whatever is it that was performing, you can just replace that. Okay, so that will not affect your downtime. Your productivity will increase because of that. Also, scalability is another benefit, right? Because you can attach it, you can add more and more units. So scalability is also there. So not like you have a fixed, just like you know rigid automation, there was inflexibility to accommodate the product changes, right? So in here also you can